requirements just to meet and to address quality. In your schedule, you have some activities for the duration just to address quality. That, of course, then you need to allocate some cost just to address quality. In the project, lesson number 2. And today we are going to cover topic E, plan and manage quality of products and deliverables. And this is very important topic, similar to the previous topics where we covered our scope baseline, cost baseline, schedule baseline. And today we are going to cover the objective number 4 at the top priority, which is quality. So let's have a look on the deliverables first. List of tools and the enablers belongs to this task. So this task, it's task number 7 under the second domain, which is process domain. As enablers, we're going to discuss about planning for the quality. So plan the quality standard required for the project deliverables. And normally this area, the plan about the quality, normally we have it very early in our project, because quality normally inherited from the quality culture of our organization. In each company, in each industry, we do have some set of standards, regulations that we have to meet in order to deliver our project. And this is where normally we have these standards ready. So we are going to touch on planning and recommend some options for improvement. And this is the main area about quality. Always we need to think how we can improve our work, how we can avoid having any defects or errors in the outputs as deliverables, services, results from our project, and continually survey project deliverables, because we need to ensure that we are on the right track and we are going to deliver the quality requirements as requested from the number 1. So these are the main area about enablers. Let's have a look on the list of some deliverables and tools we are going to touch in this topic. Of course, your quality management plan, same as all knowledge area. Always we start with planning for that knowledge area. And always remember, plan only answering how. How you are going to handle the quality, how you are going to inspect, how you are going to do your audits, and so on. Define some quality metrics for your project. We'll cover on that. Quality assurance and quality control, so famous terms in quality. Some tools, they are very interesting too, we are going to touch. Cost benefit analysis. Cost benefit about the quality itself, the cost of the quality activities versus the benefit expected. Because in general, quality means cost. We are going to cover that, of course. And the cost of quality, we are going to discuss what type of cost we might have in our project just to meet the quality requirements. And benchmarking, one of the tools. Quality audit, of course. Analysis of our business process that you are following to see how we can improve. Measure the quality, validate your deliverables, and quality measurement tools. So these are very interesting tools and techniques. The area of quality, it's extremely important for the exam because this is a very important, of course, one of the top 4 objectives of any project that we need to take care of. And we said quality embedded within your 3 baselines. It's in the heart of the 3 baselines. From the scope baseline, definitely you collect some requirements just to meet and to address quality. In your schedule, you have some activities for the duration just to address quality. That, of course, then you need to allocate some cost just to address quality. So all these activities, we have it, our inspections, the tools that you are going to use, all the audits and the visits for your projects to do some, to verify about the quality level in your project. This is all activity that means cost, time, and so on. So quality itself, it's embedded within our 3 baseline. That's why it's extremely important topic. But before I jump and discuss more in details about this topic, we need to have some common understanding about the meaning of quality first. And this understanding, very important to know how to proceed with this knowledge area. Quality in general, we have, same as scope, we have 2 dimensions of quality. We discussed about scope, we said We have the scope of our deliverables, which is, we call it product scope, and we have the scope for the project, which is the scope of our work plus the product scope. In the same concept, you need to think about the quality. Quality has a two-dimension always. It's the quality of the deliverables and the quality of our work. The processes that we need to follow in order to build these deliverables. And always in quality, our main focus is to improve our work in order to avoid having any defects or errors in our deliverables. And this is the meaning of prevention versus inspection. So we have two terms so famous in quality, which are prevention versus inspection. So prevention is keeping errors out of the process. This is some proactive approach to prevent having any errors later in our deliverables. This is where we need to focus to improve your work, to improve the framework that you are following, to improve your checklist, to improve the business process you follow. This is where you need to have audit to ensure that you are on the right track. So prevention, keeping errors out of the process. The main focus is the process, where inspection, it's keeping errors out of the hands of the customer. This is reactive, meaning, well, once you have any errors, you need to catch it. So this is reactive approach. So always in our project, we have both. We have prevention and inspection. Always we need to see how we can improve our work, but of course, before we go and deliver, I have to apply inspections. So in quality in general, prevention is preferred over inspection, but this is not a replacement. We need to have both. So in quality, in that framework on page 25, we have two processes, and this is where I want you to keep an attention. This is the basic understanding about the framework. Manage quality and control quality. Two processes. One belongs to the execution, one belongs to the monitoring controlling. Now, manage quality, this is the heart of the quality in this framework. Because manage quality process, the main focus is prevention. It's a proactive. This is the quality of our process. The main focus is the quality of our work. Where control quality process, it's an inspection. This is the main focus. It's reactive process. And the main focus is the quality of our deliverables. So let's have a look on this page 25. This is the quality knowledge area. And this is where you have only three processes, by the way, belongs to this knowledge area. It's not big knowledge area, but extremely important. And good number of questions in the exam about quality, because this is a very important topic. The understanding the framework, this is one of the core concepts about quality in this framework from PMI. The managed quality, this is the heart of the quality in this framework. This is where you need to receive the measurement from the control quality, all the outputs from the inspections about your deliverables. They are going to analyze at the managed quality level, and to see how we can improve our work to avoid having these defects in our deliverables. So this is managed quality focus on the quality of our work, where control quality focus on the quality of the deliverables. And here we have a link between the quality and the scope. If you remember, we discussed in scope about this process, validate scope. And we said the main reason why we have two processes in monitoring and controlling under scope, because one is taking care about only the scope of the product, which is validate scope, but the control scope is taking care about the scope baseline, including our work. And this control scope is taking care about the baseline, just to ensure we don't have any missing requirements, just to ensure that we are following the plan. So control scope is taking care of the baseline, try to protect this baseline of having any change only through a proper change control procedure. Where validate scope, nothing to do with the scope of our work, nothing to do with the scope of the project. The main focus is this product scope. which is part of the scope baseline, of course, but nothing to do with our work. And this is where you have a link now between validate scope and control quality, because both are focusing on the product, right, which are our deliverables. So we have a flow here I want you to remember for the exam, because we have 4 terms. We need to differentiate between these terms concerning the deliverables itself, which is the output from your work. So the story starts from this process: direct and manage project work. This is the process. In the execution, this is where you have your deliverables becomes an output. At this process, at this integration level, you are going to build these deliverables. So your deliverables becomes an output at this level. Now, before you go and demonstrate these deliverables to the customers, sponsor, key stakeholders, first, these deliverables must be inspected by quality department, right? And this is where your deliverables now becomes an input to this process first, which is control quality process. This process will have deliverables as an input to this, because they need to do inspection. Once the quality department approve these deliverables, we call it then verified deliverables. So the term now we have it as verified, means these are deliverables inspected by quality department. Then verified deliverables becomes an input to validate scope. This is where you need to sit with the customer, demonstrate your deliverables, and get the acceptance, right? So the input to this, we call it verified deliverables. We don't have deliverables as an input to validate scope, because your quality needs to inspect first. So we call it verified deliverables. Once you receive this acceptance letter from your key stakeholders, customer, sponsor, the output, we call it accepted deliverables. That means these are deliverables accepted by the customer, and they are ready to be handed over to the operation or transitions, right? This is where you need this accepted deliverables, one of the main input to this close project or phase. So in order to close any project, any phase, I need to have this accepted deliverables. This is where you are going to have accepted deliverables, one of the main inputs here, and the output, once you hand it over to operation, once you do the implementation, we call it transitioned deliverables. So 4 terms we have about deliverables I want to differentiate, because each term means input, output to a different process. This is, you have 2 flow I will ask you to remember for the exam. Once you understand these 2 flow, trust me, good number of questions, it will be so easy to solve in the exam. So this is the flow behind deliverables. So as I said, from the direct and manage and the execution, this is where you are going to have your deliverables. Now these deliverables becomes an input to control quality first, because quality, they want to inspect before you go and deliver. The output, we call it verified deliverables. Verified deliverables becomes an input to validate scope. This is where you need to sit with the customer, and once you receive the acceptance letter, we call it accepted deliverables. And now accepted deliverables, one of the main input that you need to close project or phase. And once you hand it over or you do the implementation, we call it transition deliverables. These terms as per the PMI framework. So this is flow. We have a link here. I want you to remember for the exam. So with this introduction about quality, so let's start with our discussion about this topic. So first of all, quality. So in general, quality is what? Quality, it's the degree to which a set of inherent characteristics fulfill requirements. That means it's not about building something so expensive. It's not about delivering something so fast. The main target of quality, I need to meet the requirements. This is purely very simple statement about quality. If I'm meeting your requirements, I'm delivering a very good qualified product for you. Some terms about quality that we need to understand, which is quality standards, versus regulations. So standard, this is good to follow. Standard is a document established by an authority, custom, or general consent as a model or example. It's a good to follow, same as ISO, for example. This is what you call it standard. Now regulations, no, these are something you must follow. You don't have an option. These are requirements imposed by governmental body. Depends on the industry, of course. For example, always in constructions we have some safety regulations we have to meet in our project, no matter what. So these requirements establish the product, process, service characteristics, including some provisions that have some government mandated compliance. This is what we call it, compliance. So these are something we have to meet. So that's why we have some regulations, which is de facto regulations and de jure regulation. Now regulations which are de facto, because of the nature of the work, these are regulations that are widely accepted and adopted through use. And we have de jure regulations. These are regulations that are mandated by law or have been approved by a recognized body of experts. These are two terms about regulations. So ISO, for example, is a very famous standard in quality. It's a quality system standard that can be applied to any product, service, process in the world. So these are some basic terms about quality, the difference between standard and regulations. So regulation is something we have to meet, we have to follow, where standard something is good to have in our project. So validated deliverables, we said for the products are outputs. For the product and outputs are measured against the quality standards. This is where you need to do some inspection. Now when quality standards are neither met nor within acceptable range, corrections and controls are put into actions. This is where wherever you have any variance, we need to jump and do some actions. So the project team perform the validation and deliverables are verified by the customer, which equates to validated deliverables. This is the flow that we spoke about. All project deliverables must be validated based on quality standards. And normally, since we are talking about deliverables, always our main tool, inspection, where whenever we are talking about improving our work, the main tool we have is audit. So quality management plan, we mentioned about this plan. We said this is part of your project management plan, and normally we'll explain only how you are going to meet the quality requirements in your project, how you are going to allocate the required time, resources, cost, what the standards you have to follow, and so on. So this is, and normally you are going to have this plan very early in any project, because normally we have it because it's inherited from the quality culture of the organization. Cost of quality. In general, quality means cost. If we need to meet quality requirements, we have to pay for that. Of course, not meeting this, if we just ignore or we failed to meet these quality requirements, we have to pay for that. So in both scenarios, it's a cost. So cost of quality, this is all cost incurred over the life of the product by investment in preventing non-conformance. We are to avoid this to requirements, appraisal of the product or service for conformance to requirements, and failure to meet requirements. So in general, we have two types of cost in quality. Cost of conformance, meeting the requirements, and this is money spent during the project to avoid failure. This is all type of prevention. So prevention costs, all this training to the end user, all this training to our team, this is prevention in order to improve the level of our work. Document processes, capturing these processes and analyzing these processes to see how we can improve our process. This is prevention. All the equipments we have in order to analyze our quality, this is prevention. The extra time that you can give to your team in order to do it right, this is prevention. So this is all cost just to address quality. Some appraisal cost. Example, testing. All this testing, alpha testing, beta testing on a piece of code for a software development, this is appraisal cost, which are cost of conformance in order to meet the quality requirements. Destructive testing loss, this is in construction. This is also one side. All the inspections that we do for this is all cost of conformance. The cost to ensure that we are going to meet the quality requirements. Now, the failure in meeting this requirement, we need to pay, which is the cost of non-conformance about the quality requirements. So this is money spent during and after the project because of failures. Internal failures. All this rework, once we have this inspection and said this is not accepted, we have to rework. So all this rework, scrap, this is all cost for the project. Some external failure because of non-conformance, not meeting the quality, might include liabilities to the company. Warranty work or even lost business might reach that level because of non-conformance. This is cost of non-conformance about the quality standards and regulations. So this is an extremely important area that we need to pay attention about all the quality requirements regulations. Of course, later we are going to touch on one area talking about the compliance in our project. We are going to retouch on this area one more time. Quality metrics. Metrics, normally we have it in order to see the quality of our work in our project. So description of a project or product attributes and how to measure it. This is the main idea of having metrics, how I can manage the quality of something. So quality of deliverables might be based on some acceptance range. Let's say air conditioning between this to this as temperature. This is acceptance criteria. This is, I might have some metrics, take measuring and see the outputs, or might be around, of course, even our work. A percentage of work completed on time. This is one famous metrics to measure the quality of our project. Tolerance. This is a quantified description of acceptable variation for a quality requirements. And tolerance, we are going to touch on tolerance in one example, but keep that on mind. Tolerance, the main focus is the quality of our deliverables, because normally tolerance we have it in the contract. One of the main quality requirements that we have it with an agreement with the customer. Now these quality requirements, these are the tolerance. These are acceptance criteria. Based on this tolerance, our customer, stakeholder, sponsor is going to give us this acceptance letter about our deliverables. So tolerance, main area, main focus, remember that, the deliverables. Quality audit, it's the structured independent process to determine if project activities comply with the organizational and project policies, processes and procedures. So it's an audit, internal or external, by the way. But most of the time it's an external to the project team, but it might be internal from the organization, or even external as subject matter expert, consultant, might do this audit on your project to see, are you following the quality standards in our company on how to deliver a project? So the main area in this an audit, the main focus is the quality of our work. So that's why this is a prevention approach. So it's about improve the quality performance of a project, and as we said, can be conducted at scheduled or random visit. The topics discussed or covered in any audit visit about your quality management policy. Do we have any quality management policy in this project or not? Collection and use of information, how you collect the information and how you use this information. Especially if you are dealing with some confidential information, definitely you need to have some standards, some requirements about how to deal with such information. So are you following the quality standards? Some analytical methods about especially the business process we are following. And one of the analytical methods here to analyze our business process and decide if we do have any non-added value activity in our process. This is normally we call it waste. So this is one first step that you need to think about, to just take this activity out, because this is waste of the effort, waste of the money, waste of our time. Cost of quality, measuring the cost of quality in this project, and see cost versus benefits, right? And of course, as we said, the quality process design. These are some area that any audit in a project taking care of. Some guidelines to manage quality, which is the quality of our work, to ensure that we are going to avoid having these defects in our deliverables. So number one, ensure having this random or scheduled quality audit and conducted by qualified auditors. Use one or more quality assurance tools techniques to determine causes of quality problems, because the main idea in manage quality process, which is an execution, we said the main focus here is the quality of our work, prevention, and always prevention versus inspection. We prefer prevention, but remember we need to have both in your project, of course. So that's why manage quality, this is the heart of the quality. This is where you need to receive all the measurements, the readings from the control quality process, where the inspections, once they do this inspections and take readings, all these reports normally forwarded to this process, to this area, to see how we can improve our work. So this is where you need to apply some tools and techniques to analyze the root cause of such problems. So determine the causes of quality problems, service or system or processes, like cause and effects diagram, which is we call it Ishikawa or fishbone diagram. This is, we're going to touch of course on that. Identify and implement some appropriate action to take to increase the effectiveness or efficiency of the project team's work. So the main idea of managed quality, as we said, to see how we can improve our work to avoid having any defects in our deliverables, which is, you will see audit, one of the main tools and techniques. So some quality measurement tools, and most of these tools you can apply in control quality. This is where you are going to have a lot of inspections and take readings about the outputs from your project before you go and of course deliver. These are so famous techniques: control charts and variability, Pareto Chart, statistical sampling, talking about sampling, and the statistical sampling process. So let's have a look on first one, which is control chart variability. Control chart, this is so famous tools and techniques, and normally the control chart will give us some focus on two dimensions, by the way, on the quality of our products and the quality of our process. Now this tool normally will tell the team that whether the process that we are following, whether this process is it's in a good process or it might need some attention. So the idea here, we need to have some readings from the deliverables, and this is what we call it here, the mean. I will explain this and then we'll have some example to make it much easier for you. So first of all, we agreed on a range, which is your acceptance criteria. Based on this range, you have the mean now. From the mean, you decide on the something called upper control limits and lower control limits. And then you start taking readings from your outputs, which are deliverables. So it might be dimension, it might be weight for the deliverables, any attributes about your deliverables. This is based on the acceptance criteria. For example, if I need to deliver this device, which is my device that I'm using to move between slides. If the agreement was to deliver this device at a specific weight, which is a range between two, this is what you have it here as a range. This is what we call it upper control limit and lower control limit. Then once you start now production, you are going to take readings. This is first device, second, third, and so on. Now, in the control chart, we have two rules I want you to remember. Number one, if you have any readings of this outputs from as deliverable above the control limit, which is this, the upper control limit, or you have 7 consecutive, remember this, consecutive readings above the mean, this is the mean, even if these readings are below the upper control limit, but these are consecutive above the mean, or if you have 1 reading below the lower control limit, or 7 consecutive readings below the mean, these scenarios, we consider this process out of control. This is the main idea. Having 1 readings outside this control limits, either above or below, that means this deliverable now will be rejected. So definitely we have problem in this process, because the main idea having this upper control limits and lower control limits to ensure that all our deliverables is going to be accepted by the customer. No waste. This is where you have some problem now. Now, having 7 consecutive readings above or below the mean, even within the range of the control limits, this is what represents trend in the process. That means if you have 7 consecutive readings below the mean in this scenario, that means later on, this process, you will have your deliverables below the lower control limits. It represents some trend in the business process. So both scenario, which is we call it rule of 7, the 7 consecutive readings, or if you have 1 readings above or below the control limits, any of these scenarios we consider this business process out of control. So the main idea of this control chart to see whether our business process is good or not, or acceptable or not. Is it accepted or not? This is the main area. So let's have an example and just to see what the link between the tolerance and control chart. Let's see, as we said, we need to deliver this small device as a deliverable from our project. Now, with the agreement now with the customer, which is we have it in the contract. This is the main idea, talking about the acceptance criteria about these deliverables. We agreed to have the weight for these devices are between 204 to 196 gram. This is the range that we accept. If this is my acceptance criteria, because based on this range now my customer is going to accept or reject, right, my deliverables. Now based on this, we are going to start thinking about having our control limits. So how it works? First, this is our represent the gram as a mean, which is the average. Now we have it as 200 gram. This is the mean, because the agreement was 200 gram plus minus 4. That's it. So plus minus 4 means 204 to 196. Now this is what we call it tolerance. Because remember, tolerance focusing on the product itself, on the deliverables. This is what we have it in the contract. The range for this tolerance, this is what we have it in the contract. It's a 204 to 196. Any device within this range, it will be accepted by the customer. Perfect. This is where the control chart now works with the tolerance normally, by having always your control charts are inside the tolerance limit. Why? Same here. because we need to ensure that all the outputs from our business process is going to be accepted by our customer. That's why we have it normally within the tolerance. So to achieve this, we are going to agree to have our control limits now plus minus 3. So normally how we decide on this range, going with sigma, because we decide to go with the plus 3 sigma from the mean. This is normally how we decide on the upper control limit, and minus 3 sigma from the mean. This is your lower control limits. And how we calculate sigma, and normally sigma, and this is the rule for sigma. Sigma, it's equal to the normally the standard deviation in normal distribution. I'm talking now a little bit of math, but this is for your information. But in general, sigma equal to the pessimistic or the maximum value minus your optimistic, which is the minimum value, divided by 6. Which is in this scenario very simple. It's 203 minus the minimum 197 divided by 6, it's equal to 1. So our sigma practically it's 1 gram. So if you go 3 gram from 200, 3 gram below the 200, this is your sigma. So plus 3, this is your upper control limit, and minus 3, this is your lower control limit. So now, then you start taking now readings from these deliverables. You start from the first one, second one, third device, fourth device, and so on. You continue. And so on. So now if you draw a line, you will end up with this, because this is how the good process looks like. It should be jumps ups and down. So this is where you have now two scenarios showing that this business process out of control, even if the readings are within the tolerance limit. So practically this device now, it will be accepted by the customer, but as a business process, it's out of control. We need to have a look on this business process. So this is case number 1. Case number 2, which is rule of 7. 7 consecutive readings below or above the mean. This is what we call it, rule of 7. If I have any of these, I tell that this is, of course, out of control business process. So if you see, normally the control chart showing that the process, focusing on the process itself, where the tolerance focusing on the product, the quality of our product. So this is the idea about having tolerance and control limits. Always quality, thinking about the quality of our deliverables and the quality of our work. Prevention versus inspection. This is the idea of quality. So variability indications, this is what we've discussed so far. It's a measurement that exceeds the range between the upper and lower control limits. If you have any of these readings above or below the control limits, are considered to be indication of instability of the process. This is what you call it, this process out of control, that you need to take an action. Now, variability expressed as atypical for the process or special cause. We call it in quality special cause. If you have it only 1 readings above the control limits, the upper control limits, or below the lower control limits, this is what we call a special cause or atypical for the process, and may be indication of some special source of variation. Maybe because of special cause, like at that moment some fluctuation in the power for the machine, for example, I don't know. Maybe for this period of time you just replaced your supplier with a different one, then the output becomes out of control. Whatever, we need to identify the root cause of that instability in our business process. Another famous technique also, it's in a Pareto chart. And Pareto chart following the law of Pareto called 80-20. And Pareto said 80% of our problems because of 20% of the causes. This is the law of the Pareto. So if you solve that 20% of the causes, you are going to solve 80% of your problems. So how we can apply Pareto charts? So Pareto charts has these are represent the causes that we have. In this scenario, we are talking about some restaurant complaints. Okay, we just capture some complaints we are receiving from our customers. So first step, we need to categorize these complaints from the highest number all the way down. The big number, it's about overpriced. The majority of the complaint in our restaurant about overpriced. We have another set of complaints about small portions of our meals, noisy place, and so on. These represent here, at this scale here, represent the number of complaints we receive. So here we have around 50 complaints talking about overpriced, then we have 40 complaints talking about small portions, and so on. Now, at this scale here, we are representing now the percentage. Now, if you draw this line, which represent cumulative percentage for this. So this overprice represent, let's see here, around 35% of the complaints. Now as cumulative, which is overprice plus the small portion, represent around 60. Now if you see here, with the noisy, almost it's around 82%. So 3 causes, if you solve, you are going to solve 80% of your problems. Because as the causes for this big number of complaints, you have 3 causes, normally represent 20% of the complaints, type of complaints you have about your restaurant. So 20% of this, out of this big number, belongs to 3 categories only. So 20%, if you solve, you are going to solve 80% of the total number of complaints you have. So if you just think about your overpriced, small portion, noisy, boom, 80% solved. This is the Pareto chart. Same approach you may think about in your project about capturing some readings, some measurements about your deliverables, and you need to identify the root cause. So you need to think about the causes. Once you have the causes, you need to maybe apply Pareto chart to think about what are the 20% of the causes leads to 80% of our problems. So you need to add these causes and solve it. Another one is statistical sampling, and from the name it's talking about inspection. It belongs to measurement for the quality of our products, belongs to the control quality before you go and deliver. So statistical sampling, choosing part of population of interest for inspection. Because practically if I want to inspect every single output, all the deliverables, is so costly. So that's why always in inspection we go for sampling or statistical sampling approach. Now the idea here, determine some characteristics of an entire population based on actual measurement of its representative sample. So this is the idea of picking the right number from your population that represent all the characteristics of this group. This produces a process that doesn't require inspection of every item to actually cutting costs in your quality. In order to pick this, normally we go for thinking about the statistical sampling process. So normally we are first divide the sampling data into 2 categories. Of course, depends on your deliverables, but in general they are either attribute or variable. And then this helps reduce overall quality cost when used during quality control. So what are these attribute variables? Sampling data. Attributes, anything talking about yes or no, black or white, accepted or rejected. You don't have this margin, you don't have tolerance. Thinking about this device, same example, if our agreement, it must be 200 gram no matter what. So whatever I do inspections, any device not equal to exactly 200 gram, it will be rejected immediately. This is what we call it attribute sampling. So again, depends on the deliverables. Or you can go for variable, which is having some margin in the tolerance, like temperature, dimension, normally, weight, normally have from 2. Whatever you have this margin from 2, this is what you call it variable sampling. So first you decide about type of data, whether variable or attributes, then you can do these readings, apply these measurements, present this information in a chart like Pareto Chart, thinking about the root causes, and then based on this analysis you need to do some corrective actions, right? So this is the idea of statistical sampling process in quality. So here's some guidelines to controlling project quality. So number 1, conduct inspections to detect quality errors of a project work is ongoing. Always all our deliverables must be inspected before you go and deliver, of course. Use Pareto diagrams to focus corrective actions. Fixing the 20% of the causes leads to solve 80% of your problems. Remember this golden ratio from Pareto. On the problems having the greatest effects on the overall quality. Control chart to analyze and communicate variability of a process to see if our work, our business process is accepted or not. Identify ways to eliminate causes of unsatisfactory result. So any extra step we have in our process, take it out. Check your checklist. Maybe you have some issues there. Maybe you have some steps that you need to add while you are doing testing. Maybe the type of data that you are collecting. So use some flow charts to identify any redundancies. Analyzing your business process, this is the idea. If you do have any redundancy, or maybe you have some missteps in your business process, or the source of quality performance problems. This is the idea of analyzing our business process. Initiate process adjustments by implementing corrective or prevention action. Necessary to bring the quality of work as acceptable level. This is the main focus of managed quality, how to improve our work. Continue to monitor, measure, adjust your quality throughout the project life cycle. So as a summary, remember quality always talking about 2 dimensions. The quality of our product and the quality of our work. Prevention, this is the heart of the quality. This is where you have managed quality process. Inspections, extremely important also. Before you go and deliver, I need to do inspection. So use all these tools and techniques. Quality is the objective number 4 and the priority for any project. And with this, we are done with the quality. We just covered the quality. So far, we covered our 3 baselines. On top of that, the quality, which is the heart in any project. And so far, you are moving extremely well. You covered very important topics so far. But let's keep moving forward and let's continue with our journey in starting the project. And next session, we are going to cover topic F, integrate project planning activities, which is your level at the integration level. So keep it up, keep the power, keep the momentum, and I'll see you in the next session.
或者你重新复制一下。
这只是可以用那个东西看。
或者你直接重新复制一下。我周一做的时候也是这样，很奇怪，好像是有公式那个就是你没有看到有公式，可能就是不行。
会干嘛？你放在厨房那边吗？那以后搬家不是很累？
这到底是啥意思？
这是我刚才
哦，买简易的，我以为买很贵。
可能有公式。
有公式，这么便宜，办公室的材料不能查是吗？运动卡不能查。
就是你把后面那张表要再去重新那个一下。
那可以便宜的买一个几十块嘛，不用买太贵，便宜的买一个。
不是这个表的问题。
我们再回去，我再试试。
这是后面那张表的问题。
这个没有问题。
后面那张对应表。是这个表的问题。
这表没有公式，没有啊，这表你看在这里用那个上面还能查得到啊。
所以你就把它复过来这边啊，就不要带公式，看一下会不会好。
没有公式。
是看不到公式，但是它就是不行。但是你把它复过去可能就可以了。
不是，它这个是我在这边用公式也是这个范围啊，为什么这里就能查得到？
对啊，你看你这个东西复过来这边就可以了。试一下，你先试一下看。其实是直接你要你在你这个没有格式的。这样你试一下看。也不行。
挺奇怪的。因为我之前没这么套过，我也不懂它到底是。
因为我那一天做那个表。